Good morning, dear student. It's your tutor, Heman Hassan. This is the lecture of Organic Chemistry 2, Lecture 3, Practical Organic Chemistry. Welcome to KUST. Today's lecture is column chromatography. As we have studied in the theory, we have stereoisomerism. Basically, we have enantiomers and we have diastereomers. Although we have chemical reactions apart from isomerism, but all of them, the isomers, the diastereomers, the enantiomers, and the components of the chemical reaction can be easily separated with a potential technique we call column chromatography or flash chromatography. Basically, the descriptive photo here illustrates how the components of a mixture can be separated. Let's start with a definition. Column chromatography is an analytical technique that used to separate a single component or a desired product or a drug product from the mixture of the unwanted materials as a result of a chemical reaction or as a result of a mixture of RNase product or a mixture of diastereomers. So if we have two enantiomers, if we have two diastereomers, if we have multi-component chemical reaction, one of the products is desired and the rest of the products are not desired. So we have to get rid of the unwanted product and separate the pure product as a single component, 100% purity. In order to obtain that, we use column chromatography to separate the fractions. Either they are liquid or solid. In principle, if we have a mixture of several components and one of the component is the desired product, the rest of the components is unwanted material, we need to separate it and get rid of them or use it for a different purpose. But the idea is obtaining the product that we want to have as pure as possible. How we do that? We use silica gel or we use alumina. What are they? They are stationary phase. These stationary phase are solid. So we have something called stationary phase. Different stationary phase can be used for different purposes in column chromatography. For today's lecture, we are doing the experiment using silica gel, which is a white powder. Remember, it's a toxic substance and bad if you inhale it for your respiratory system. How we can separate the components throughout the column of silica gel? The column is filled with the silica gel has been wet in advance by the mobile phase. The mobile phase in today's lecture must be liquid. This liquid could be a single organic solvent or a mixture of two or more than two organic solvents mixed together with an appropriate ratios that gives a desired and acceptable separation. I will pause sometimes during the slides in order to give you sometimes to write your notes or pose me for a question. So the component with higher affinity to the stationary phase. Remember, stationary phase is polar. The mobile phase is polar or non-polar or partially polar. So we can play with the polarity of the mobile phase, but the stationary phase is fixed polarity. We cannot change it. Either we have to use alumina or we have to use silica, or in some experiment we are using resins, and the resins are a big class of stationary phase. They have different names, brands, and trademarks, can be used for different purposes, especially for water purification. Let's go back to the column chromatography using silica gel. The component with higher affinity will stick to the stationary phase and eluted lastly. The component with the less affinity to the stationary phase or less attractiveness to the stationary phase will move faster and eluted firstly. If you look at the picture here, look at the column 1. We have blue stationary phase, which is silica gel or silica powder, and at the bottom we have a tab to control the elution rate, and on the top we have a loaded sample. Can you see the green stuff? This is the sample. This sample contains several components. One of them is the desired product, the other one is unwanted. But these two products have different affinity, different interaction, different polarity, different sticky rate to the stationary phase. Some of them is very sticky, bind to the stationary phase very strongly, as the orange one is, and the other one is weakly attracted by the stationary phase, so it eluted first. So the two component, which one comes first? The green one. Why? Because it has less interaction, weaker interaction, less polarity, less affinity to bind or stick to the stationary phase. But the orange one, completely opposite. What is the pink one? The pink one is the mobile phase. What is the mobile phase? It's the solvent. It's an organic solvent or a mixture of organic solvents. Can be used to separate, to differentiate the separation. So the mobile phase has a great role to help the separation, efficient or inefficient. Basically, in the last picture, which is photo 5, we eluted the desired product and undesired product separately. So in figure 4, we separated the green one from the orange one. Which one we wanted? We separated, and the other one we can eliminate it. How we can make sure that the green has completely separated from the orange one? We use TLC, thin layer chromatography. You have studied thin layer chromatography in your first semester. So this is the column chromatography setup. What we need a long, thick column, which must have a tab at the bottom to control the flow rate. Then we have to put some glass wool or cotton. Then a little bit sand. Then a little bit of sand. Why the cotton and sand? To not allow the silica powder to come and elute with the mobile phase and the product. So to separate and to stay the silica powder fixed in their stationary phase and not allow it to pour off with the solvent, which is eluent or which is a mobile phase, we use sand and glass wool. Also, at the end of their silica powder, we cover it with a little bit of sand. Why? It's heavier. When we add the mobile phase, it doesn't allow the stationary phase to move, because any disruption, any distortion in the stationary phase there, it affects the rate of the separation, and it helps tailing. Tailing is something we don't want it. We will discuss it later. As we have studied in the previous slide, the thin layer chromatography is similar to the column chromatography, but the thin layer chromatography is analytical technique. It helps the environment that require in terms of polarity for the column chromatography, and it tells us whether the separation is accepted or separable or non-separable by column chromatography, and to play with the polarity helps better separation. How we can play with the polarity in column chromatography? It's hard, and sometimes we lose one of the products, but in TLC we use a drop, very diluted solution mixture of the mobile phase and the products mixture. So basically the TLC is a micro scale of column chromatography. It helps us as how separable they are. The doability of the procedure of column chromatography has been used or will be used for the separation of a certain component. Like you see here, we have two different particles, particle A and particle B. By adsorption with a different rate and attraction affinity, they bind with the stationary phase, and the mobile phase will make them to be eluted. The stronger one stay longer and the weaker one will come first. As you see, the blue balls has already eluted in picture C, and the purple one still on the stationary phase. By increasing the polarity, the purple one will come as well. So if we are using two polar solvent, separation is not doable. If we are using too weak, the blue can stick on the stationary phase and it's not separable as well. So we have to play the polarity in a range that allow a better separation. Like you see here, the process of separation is starting and going on. They are both on the stationary phase and they are both moving downward with a different rate. Remember, the column must be upside down in order to do the procedure, to apply the procedure. Here we have a question. The column is upside down from the TLC. So a large RF for the compound means it comes out first or second. Think about. Let me revise a little bit about retention factor. Retention factor, by the definition, is the distance traveled by the spot or the component divided by the distance traveled by the solvent or mobile phase. So larger RF means what? Means the distance traveled by the spot is nearly similar to the distance traveled by the mobile phase, but it always smaller. Never ever this distance traveled by the spot will be higher than the distance traveled by the solvent. Why? Because the spots are in the solvent. The solvent should migrate to somewhere, then the spot will follow it. The spot alone cannot migrate without a solvent. So as big as means when the solvent eluted, then after it, exactly straight away, the spot will comes out. That means this compound is less tightly bounded to the stationary phase. Now you have an idea, the bigger RF which will come first or the smaller RF. Keep the answer in your report. In practice, we have to be aware that we have to prepare the column in advance. How we can prepare the column? First, we pour adequate amount of the stationary phase in a beaker. Then cover it with a mobile phase. The mobile phase should cover the solid powder of the stationary phase, which is silica powder, in today's lecture. Then we stir it very well until we make a very wet solution, can be poured easily. Then we close the top of the column. We put the glass wool or cotton or wool. Then we pour a little bit sun, like 3 millimeter or 5 millimeter. Then we pour the solution of the mobile phase and the silica, which is stationary phase. And we allow it to stand. We allow it to stand because the silica will settle down and pack. Remember, the silica powder never ever must be dried. The silica powder never ever should be dried. So it should be wet and covered by the mobile phase. In order to secure that, always keep the level of the mobile phase 1 inch above the stationary phase. And fill it with the mobile phase, then flush it. Why you have to flush it? In order to pack and compress the mobile phase. Then cover with a little bit of sand, just 3 to 5 millimeter. Remember, don't forget that never allows the mobile phase to pass beyond the upper level of the stationary phase. Then otherwise your stationary phase will be dried and you cannot fix it easily. When you have bubbles trapped between the stationary phase, that means this bit is paralyzed. It doesn't help you with the separation. And this bubble of air will not easily escape. Something that you have to consider practically. Preparation of the column is important. Then loading of the sample is important. Choosing the solvent. I told you in previous slides, if you are using two polar, both of the component will eluted together. If you are using two non-polar mobile phase, both of them will be sticked to the stationary phase and none of them will be eluted. How you can do that? Start with less polar in the TLC plate. Then increase the polarity as long as you get a better separation. That means the distance between spot 1 and 2 on the TLC will be big. As big as the distance, as better the separation of the component. This is the list of the solvent. Which solvent you should use? Which solvent you should use? It's not a wild choice. Randomly pick a solvent that you have it and available in the laboratory and use it. You have to play with the less polar and increase the polarity as well and so on until you get a better separation with higher resolution. Higher resolution helps you to separate the components of the diastereomer, of the enantiomers, or the components of the chemical reaction. And this is defined by the separation capacity. Sometimes you have to use more than a solvent. Sometimes you need a little bit polar. If you start with alkane and alkene is not good enough, aromatics not good enough, what do you do? And ether is too much polar. What you should do? Mix a small amount of polar solvent into a non-polar, like ethyl acetate and hexane. So the length of the column, not the entire column, the length of the stationary phase, the height of the silica amount, and the diameter and the grade of the silica gel, I mean the size of the powders, has effect. And this table here illustrated, and there is a paper provided for you published in 1978, is very good to well define the idea of column chromatography. We have two types of column chromatography. One of them is gravity. We allow the solvent to be eluted under the pressure of atmosphere or under the gravity attraction of the mobile phase. And the other one is flash chromatography. We use a blower to put air in a secure closed air system. Sometimes we have to use nitrogen or argon. Why? Because the product we have is air sensitive. If the product is air sensitive, we use nitrogen gas or argon gas. Remember, argon is more expensive than nitrogen. So basically you understood the idea of preparation of the column, the application of the column, chromatography. We have a more advanced technique, computerized, instrumented technique, which is called high performance or high pressure liquid chromatography. We use a machine to separate the components of the mixture. Sometimes it's hard to do the TLC, or the TLC would not give you a complete figure of the idea of the separation, or it's not efficient enough to separate all the components together. You might need 1 meter length TLC, which is impossible to have it or to obtain. The highest TLC plate is 20 centimeters. And basically we use 7 to 10 centimeters height TLC plate. In that 10 centimeters, we cannot separate it, or we cannot have a good idea about the components of the mixture. How many components do we have? So we use high performance liquid chromatography. What is that? Here the column is not half a meter or 1 meter. It's more than 10 meter. And it's capillary. We use micro to nanograms of the product and we dissolve it in appropriate solvent. In a very, very economic scale, it gives you the better separation idea. Can we use HPLC for the real separation of 2 grams of product? No, because the column is too small. And the vial we are using is 1 cc, 1 milliliter. So it gives us the idea of the components, and then we use mass spectroscopy to identify the component, which is not our discussions for today. When the HPLC gave you the idea of the components, then you can use 2-dimension TLC, thin layer chromatography, or using different solvents at different time. Firstly with the non-polar, then with the slight polar, then increase the polarity until you separate all the components. The application of column chromatography uses it to isolate the active ingredients from the natural product or from the chemical reaction mixture. It uses also to separate the components of a mixture used to determine the drug estimation and drug formulation, also the drug expiry for the chiral drugs, because the HPLC technique can separate the R and S enantiomers from each other. And like we studied in a previous lecture, S-ibuprofen and R-ibuprofen has different activity, and for some other drugs the S is completely different than the R one. So in order to separate the active ingredient from the other components, we use thin layer chromatography and HPLC to have an idea which column chromatography setup, solvent polarity or mobile phase polarity, or which stationary phase, or how long column, how much silica we should use. We have we have different types of column chromatography. For today's lecture, we are using only adsorption column chromatography. And we have partition column chromatography, gel chromatography, ion exchange chromatography. We will explain that in the supplementary documents that you will have it at the end of the lecture. It is not mandatory, but you have to know the name of each of the techniques and the principle of working each of them, but application and other details is not required and is not wanted to know. This is their experiment procedure, which we explain it in detail here, briefly outline it for you guys. Wish you enjoy the lecture. And here is a video tutorial. I'm playing it with you. Thanks for the University of Leeds that made this video public for everybody. So we need piece of cotton, glass wool or wool. That's the column that we have. Then we have to fix the column with 2 clump, not 1. So just a little bit of sand has been poured to the bottom. Then we have a mixture of silica powder and the mobile phase. Note that it says silica celery, which means the mobile phase and the stationary phase are a celery together, but pourable. Can you see that? The white stuff. Within the time, the silica powder will goes down. And we have to rinse the column and flush it in order to pack the silica. Don't worry about the video quality, I will send it to you separately. Can you see? Now the silica powder is compacted. Why? It's settled. It's just to shake and to make it more compacted. Because we want as less as space between the particles of the silica. Then we have to lower their mobile phase, but above the stationary phase. We have to dissolve the sample in a little amount of silica. Remember, this is not mandatory, this is not compulsory. You can dissolve it in the mobile phase alone, but remember, you have to load the sample, addition of the sample to the column called loading the sample, with using glass pipette. And you have to rinse the container of the sample in order to avoid losing any amount of the sample. And then we add mobile phase. Remember, slowly. Why we add a little bit sand here before adding the mobile phase? In order to not allow the surface to be distorted. Then we start collection. Remember, if your product has a color, you will see the color in the element. We collect the sample in fractions. Basically 20 fraction, 40 fraction or 60 fraction we collect. Then we follow by TLC until no spot of the desired product will be seen. Then we take these fractions away and we bring another set of clean test tube to collect the second fraction or the third fraction or the other one. Thank you for listening. Wish you enjoyed the lecture. Please don't worry about emailing me how many times you want. All the information to contact me are available online on my website and here as well. If you need me to talk to you, to discuss something with you, please just arrange an online virtual meeting and I will be more than happy to talk to you and discuss anything. Thank you so much.